All right, welcome back, class. This is classwork 10.5, more applications of exponential growth. In previous sections, we have been examining quantities that grow or decay by a multiplier, known as the growth ratio. In today's lesson, we are going to apply your understanding of exponential functions to quantities that are growing by percentage. John owns a rare baseball card, which is currently worth $300. An appraiser has told John that the value of the card is increasing by about 4% each year. John expects to sell the card as soon as its value is over $600. How many years will the owner wait before selling the card? So first thing we're going to do is A, how can you determine the value of the card after 1 year? Be prepared to share your ideas with the class. Record the values in the table. All right, so we want to take that $300 and we want to multiply it by 4%. Unfortunately, we can't put percents into the calculator, so we do have to move the decimal and turn it into a decimal. So anytime we turn a percent into a decimal, we move it 2 spots. 1, 2. So that number will become 300 times 0.04. If we put that into the calculator, we get 12. So then that's the amount that it's increasing by, so we have to add that to the original. So my original was 300, so 300 plus 12 equals 312. So the value of the card now after 1 year is at 312. Question B, how can we determine the value of the card after 2 years? So we're going to do the same process. We're going to take the amount that it is right now, which right now it's 312. We're going to multiply that by the same percentage, that 0.04. When we do that, we get 12.48. So once again, we're going to add that to our original, which is 312. When you add that, you get 324.48. Right, question C, use this process developed in parts A and B to complete the table. So your next step is going to be to multiply 324.48 times 4% and add it to that one. Okay. Go ahead and finish the chart, fill in 3, 4, and 5 years. Pause the video, and when you come back, we'll go over the answers. All right, excellent. So we finished the chart here. You can see we did have to do some rounding, so make sure that your rounding was the same as mine. How I got this number right here is I took 324.48, I multiplied it by 0.04, and then I added that to 324.48. And then I did the same one to each. Please let me know if you have any questions or if you did not get the same answers as me. Okay, question number 2, or letter D, do you think this is linear or exponential relationship? If the equation is linear, state the rate of growth, and if it's exponential, state the growth ratio. So in order to see if it's linear, we should be adding by the same amount each time. So how do we go from 300 to 312? We add 12 to that. And so then that pattern should be consistent. But if we add 12 to 312, we get 324 exactly, not 324.48. This is not going to be a linear pattern. So let's look at multiplying. So if we want to figure out how we multiply it, we've got to take the bottom number and divide it by the top. So punch into your calculators 312 divided by 300. All right, perfect. You should get 1.04. So in order to go from 300 to 312, we multiply by 1.04. Now let's see if that works. So I punched in my calculator 312 times 1.04. And that does give me 324.48. So this does work. And if you try it for every single one of them, it does work out. So what this tells me is this is no longer a linear equation, but it is going to be exponential. That's exponential. And then my growth ratio would be that answer. So my growth ratio (1.04). So let's write an equation that will determine the value of the card if we know the number of years. So exponential is always y equals my initial amount. So when x is 0, my initial amount is 300 times my growth ratio of 1.04 to the x power. Use your equation to determine the number of years the owner must wait before selling the card. So in order to figure this out, we know that we want our answer to be at least 600. So we've got 600, and then we've got our equation of 300, 1.04 to the x. And we're okay if this answer is greater than 600. We just need it to be at least 600. So what I'm going to punch into x is I'm just going to guess and check here. So let's try after 10 years. So I've got my calculator, and I'm going to type in 300 parenthesis 1.04 end parenthesis the exponent button, which is right above the division, 10 years. I can see that I'm only at 444. I still need to go way beyond that. So let's try after 20 years. 300 parenthesis 1.04 parenthesis exponent button 20 and enter. And now we are at $600. We're over $600. So we know my answer is somewhere between 10 and 20 years. Go ahead and guess and check and see if you can figure out what that value is. And pause the video if you need to. All right, perfect. And as you can see on the calculator, if I do 17 years, I get $584. But if I do 18 years, I do get $607. So my answer to this one would be 18 years. Now I know it's in between 17 and 18, but we can't sell it before it's $600, so we've got to have an answer of 18 years. And then my last question, if the owner decided not to sell the card, what would it be its value after 30 years? So once again, take the calculator, type in 300 parenthesis 1.04 end parenthesis to the 30th power, and I get $973.01, but I got to look at my other decimal. That's going to round that up to 2 cents. So my answer for this one would be $973.02.